All right, so tonight's homework requires you to go in and create models. You're going to draw a Bohr model of the following atoms and list the PEN, number of protons, electrons, and neutrons for each atom. Then the following day, you can use the numbers to identify the element and draw Bohr models of each element. Now, in order to do that, you got to be able to do this. Here we have a periodic table of elements. And on this periodic table, this chart, it provides you all sorts of information about elements and their individual atoms. So you are going to learn to read an element key. We're going to take one sample. We're going to take cobalt. So on your paper, you're going to draw what I draw. Make a box in your notes. Cobalt is element 27. And I'm going to round off the number on the bottom to 59. Now, I'm going to draw a box here, and I'm going to explain to you exactly what that means. Okay, so you have what's called an element key. This gives you a breakdown of what you're looking at. Each element listed on a periodic table contains information. So the number there is called the atomic number. Now, based on the video that we watched, the atomic number tells you something about the atom. It tells you the number of protons found in each atom of cobalt. And that number is 27. So every cobalt atom has 27 protons. Number of protons. This little box here that I drew is the state of matter. If it's a box, then it'd probably be a solid. Cobalt, the word itself, is the element. And then last 59 on the bottom, that's the atomic mass unit. Or units. And that tells you the number of protons plus neutrons. So when you add the number of protons and neutrons, you get the atomic mass. Up top, in a quote-unquote normal atom, the atomic number tells you the number of protons and electrons. So sometimes, in a lot of cases, the numbers are the same. All right? And so at room temperature, this is a solid. Now that gives me all sorts of good information there. But now we got to make sense out of it. We're going to draw an atom, but before we do that, we need to figure out the components, the PEN, the number of protons, electrons, and neutrons. So based on this, the atomic number is your number of protons. So the number of protons, Kevin, how many protons would there be in a cobalt? Nope. Anyone know? Malik, 27, because the atomic number tells you the number of protons. How many electrons are there in a cobalt, normal cobalt? 27, because the number of protons is usually equal to the number of electrons. Now, the tricky part is how many neutrons are there? Nope. Nope. 59 minus 27. Why? Yeah, so the atomic mass number is protons plus neutrons. So the element key gives you the number of protons. It gives you the number total. You just take the total number, the mass units, and subtract the atomic number. So we get 59 minus 27, and then we get 32 neutrons. And so that's pretty much what you're going to be doing. You're making sense out of these elements, the keys here. And that's the data you get. Now, as you go up in grade, the periodic tables become more complex, and they give you electronegativity and stuff like that. And you'll get to that later, but in eighth grade, we're going to keep it simple. So that's what you need right there. So now we're going to draw an atom on it, right? So the other day you looked at the brain plot videos that showed the different models. We're going to look at one model. This is the Bohr model. So which two particles go inside the nucleus? Anyone? Protons and what else? Protons and neutrons. So I'm going to put a P. I'm going to put an N here because I don't feel like drawing all of them. So how many protons are there in a nucleus? In the nucleus of a cobalt? How many protons are there in the atom, the nucleus of a cobalt atom? You just did it. 27. How many neutrons are there? 32. Okay. So how many electrons? Somebody said 27. Okay. So, all right. Basically, here's the deal. The model that we're going to go over is a very neat one, but in reality, the electrons could be anywhere because they're moving at the speed of light around it. So we're going to make 27 little E's around it. See electron cloud. So keep count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. They never go into the nucleus. 13 under normal circumstances. 14, 15, 16, 17, 18, 19, 20, 21, 2, 3, 4, 5, 6, 27. And this is your electron cloud. So they basically exist around, flying in every direction around the nucleus. Never typically into it. Because when that happens and they collide, something else happens, and that's deeper chemistry. Okay? But that right there, that's not the Bohr model. That's just you could just say that's the cloud, electron cloud model of the atom. You have 27 protons, 32 neutrons, and you have your 27 electrons that can be at any point in time around it. They move fast. And that's what you got to do for homework.